Hey, welcome to Top Shelf Tech. I'm Jeremy Nees, and today we are talking about the SOAR, the SOC, security command centers, and a whole lot of interesting topics around how the world of security operations is changing. Today I have joining me Alex from StrikeReady. Alex is the CTO of StrikeReady. Alex, do you want to just start with a little bit of an introduction to yourself and your role?
Sure. Yeah. So Alex Lanstein, CTO here at StrikeReady. Like many of the people at StrikeReady, we were all kind of worker bees at FireEye back in the day. So we started at FireEye in 2007. Happened to be a great place that helped reshape security from a sandboxing perspective, and a dynamic analysis perspective in general. But we helped build that team and that product, and so we were there for between 10 and 15 years, depending who you are on the team. And then I went to Facebook for a little bit. I led a number of espionage investigations from some South Asian actors targeting people on platform. But back in a startup now, really prefer to be a builder and get on things at the ground floor.
Cool. I didn't know that about your background. That's interesting. Hey, Alex, StrikeReady. Why was StrikeReady built? The market's pretty saturated with SOAR and SOAR type solutions. So what was the problem, the team at StrikeReady were trying to solve when they went, look, we're going to go build this platform?
Yeah, that's a great question. Yeah, I mean, so certainly like the security operations center, whether you call it a single pane of glass or, a one screen to rule them all, people have tried to solve this problem for many generations of tech. The problem of I've got lots of tools. These are disparate vendors, heterogeneous environment. I have a different vendor on my email, my endpoint, my network, all those sorts of things. People have tried to solve this with XDR. They tried to solve this with SOAR products. And we think that we have some unique capabilities that overcome some of those challenges. So the big platform players obviously have the technical chops to be able to build a tool that will work with third-party vendors, but it's difficult to think that a big vendor, a big firewall vendor, is going to make a platform that works really well with one of their competitors. But lots of environments have multiple firewalls. Lots of environments have different EDR tools. Lots of environments have like multiple layers of email security and identity and go down the list. So one of the problems that we're trying to solve is that we don't sell underlying detection technologies. So we don't have any of those natural business frictions where, if you have Jamf on one endpoint and CrowdStrike on another, and maybe you have Windows Defender on a bunch of your servers, like we want to give you a homogeneous experience where the alerts look the same, the fields are mapped to be the same thing, all the actions you want to take. You don't need to know the underlying syntax, underlying schema of the reporting technologies. So the problems that we're trying to solve are not new. Enterprises want to be able to do actions. They want to be able to do investigations. They want to be able to triage threat intel, and they don't want their SOC people to have to know exactly how each individual tool, like how their API works, how their search bar works. What their shortcomings are of, this one can do MD5s, but this one can only do SHA-1s, or this one is moving to SHA-256. There's all sorts of little small issues that we're trying to solve in our platform.
Interestingly as well, I was first introduced to StrikeReady 3 years ago, which is still pretty early days for the team back then, and I had a couple of conversations with the founders. And one of the things that struck with me at the time, and we were just rolling our first gen SOAR into our SOC at that stage, and the comment I got is, you're not going to get the benefits from automation that you think you'll get. And I thought, well, that's a fairly bold claim. And I think 3 years on, looking back, like that was 100% on the money. 100% on the money, because too much of the kind of workflow based automation in a SOAR is very much like RPA for security. And that works well when you've got if you've got some very static and very standard workflows that you're going to operate regularly. But when you're sort of in an investigation and you're sort of pivoting and doing all these things, all of a sudden it becomes hard to automate all the actions and pivots and stuff you might want to take. And I think that's probably one of the pieces that's ran true with me with sort of StrikeReady is going, actually, this conceptually is quite different to a SOAR, although it might be just because it aggregates security alerts and inputs and outputs and stuff, kind of gets cast in the same heap.
Yeah, exactly. Yeah, and the SOAR, the SOAR components are some of the core like development cycles that we spend building. Obviously, you want to make all your tools work together, but we don't want to expose that to the customer. And there's a number of problems that SOAR vendors run into, and obviously, if you have an infinite budget or you have the desire to have software developers in your SOC, which lots of organizations do. There's lots of organizations who have infinite resources for security. You can see them on TV, and they say like, no, we want to buy a high code SOAR product. We want to write Python ourselves. We want to be able to update these. The tip of the spear. These people want the flexibility of writing code. But most people, the SOAR products in general, I mean, kind of like you were referring to, that the APIs that they're connecting to, they change all the time. And I mean, we integrate with hundreds of products, hundreds of individual products. I don't mean actions, like individual products. The APIs change all the time. The functionality is improved, or features that you might be using were deprecated. It's multiple full-time jobs to keep up with these APIs. But then also, the customers, they want to swap out the vendors. Like, hey, I have X EDR today, and it used to be good, and now it's not good anymore. I want to go to Y EDR, and like the resources, the cycles that takes for development to get you confident that yes, now we can turn off this vendor and go to that vendor across your whole stack. People just don't necessarily want to do that. So that's kind of the first thing that we solve with people. The second big thing is that, like, when you're talking about alert triage, or you're talking about threat intel triage, it's not rocket science what the SOC wants to do. Like when a SOC operator gets an alert from an endpoint or from a network device, like you get an EDR alert, the SOC person, they want to look at like 100 things before they even sort of dig into the alert to figure out true positive, false positive. Like they want to figure out, like, okay, who is this user? Like, what's their identity? Who do they work for? What business unit are they in? What workstation is this? Has it gotten any vulnerability scans lately? Is it up to date with patches? Like, what was the user doing at the time? What were they browsing the web? Like, give me their click data, give me their proxy data, give me the DNS data. What was going on the endpoint? Like, give me the telemetry. All those sorts of things. Those aren't unique questions that the SOC operator wants to do. Like, every single person wants to do that. But in these very flexible, like super technical SOAR products, you have to like build each one of those little integrations. When to us, it's like, yeah, of course you want to know all of those things every single time there's an alert. Like, that's just natural.
Yeah. So I think one of the things from a StrikeReady perspective that I've seen recently that I was like, okay, that's cool, is this sort of shift from to these asset views, right? So an identity as an asset, and being able to look at an identity and see a lot of information collated around that identity, or similar with, say, a device. And I think probably with a lot of traditional SOARs, or even going SIEMs, where they're used as aggregation points, a lot of it's sort of this time series data, and it's a flow of data and a flow of alerts and a flow of this kind of stuff. And then to your point, you go out and reach for stuff. Being able to visualize it and very quickly go, right, I just want to look at this individual and see what are, do they have MFA turned on? Do they have this, that, the other thing? Actually being able to get that view in your security command center, kind of from a cognitive perspective, means that it's just super simple to get a understanding of the context surrounding this alert, as opposed to, again, trying to have to go through almost lists of information, if that makes sense.
Yeah, absolutely. I mean, a lot of what we do is good plumbing. It's not that it's not rocket science, but like just being able to display the information in a sensible way, understanding what information you're going to want to gather based on an alert or an intel hit or whatever it is, and then doing it for you. Like, just you don't want to ask every time, or if you do want to ask, being able to automate that. Oh, I noticed you went and searched for this IP address in your Splunk or your Sentinel or your data set or your whatever. Do you want to do that every single time when you see one of these alerts, and then suck in that information and display it in this nice view? Yeah, it's just, little bits of learning from how people are using the product and just making sure you only have to do something once.
So you and the team work with a lot of different security operations teams. What are the kind of major challenges that you see facing these teams today, and how would that contrast to say how the challenges that you saw 5 years ago? What's changing for security operations teams?
So I guess from like a challenge perspective, the biggest challenge, or one of the biggest challenges that people have, is around fast triage of like unstructured threat intelligence. Like, SOC teams are constantly, people are constantly like sending you things on Slack or email or chat, or they print something out and like they give you some threat intel report and they're like, oh, like go and look at this thing, or like, hey, are you aware of this? And so much of the challenge that people have is that all of that work, this is like I don't know if it's an unacknowledged truth or an unknown truth, but 99% of the threat intelligence that you read is not useful to the organization. And it's not useful because like it happened to somebody else, it didn't happen to you, or you weren't vulnerable to it, or your sector wasn't targeted, or you just didn't get hit for some reason. So the SOC operator is doing all of this work. So you're extracting IPs and domains and hashes and URLs, and maybe you're going to check your alerts, and that's going to take you some period of time. Maybe you're going to check your log sources, whatever your telemetry is. And 99% of the time, based on the numbers, like you don't find anything. So the SOC operator does all this work, and then at the end, they're like, oh, I did all this stuff and we're fine. Like nothing hit us. So they get kind of burned out, and they just end up not wanting to do all that work in the future. So you get that kind of 1-2 punch of burnout, plus like in the future, like, I'm not really, I'm not going to look that hard for this thing. Like I'm probably not going to find anything. And it takes like fairly advanced people to be able to do that work. So you're burning out your best people. But the actual challenge is that like, okay, how do I do this? And only show me the stuff that has interesting threads to pull on. Like, oh, you saw this network connection to this IP, or that someone made this DNS request 3 months ago, or yeah, we did see a process with that name executing on a temp or something. Being able to like triage that stuff very quickly and only show threads worth pulling on is one of the big challenges.
Yeah, I think probably one of the things that we've seen with StrikeReady as well is that teams kind of been able to move away from, say, focus on detect and response to that stuff where you get an alert through and it needs to be responded to, and very quickly to actually spending more time up front going, there are new advisories out. There's this new threat intelligence information, new vulnerabilities. How do we take that information and actually very quickly establish, is this a risk? Is there anything we need to do? Can we monitor for this in particular ways that we're going to then highlight if that activity is occurring? And I think that's, that kind of element is incredibly valuable, right? Because we've focused a lot, I think the industry's focused a lot on EDR, popping up, sending alerts, and identity sending alerts, and kind of at that end of the spectrum, as opposed to what are the things I can do before I even potentially get an alert to try to minimize my risk, or make sure if I do get hit with something, I'm in the best position possible to be able to defend against that.
Yeah. So certainly, shifting from reactive to proactive is something that people want to be able to do. And one of the first principles in that is just understanding what you have and what's installed and what the story of vulnerabilities are in those assets or in that software. So like one of the things that we do is like we help build software databases for you. And vulnerability databases. And the way that we do that is by working with your EDR. With your EDR, we'll profile like what's running out of program files, like what's installed. So we'll build software libraries for you, just using like your native EDR capabilities, so that you can understand your vulnerabilities all in one place. So if you have a vulnerability scan from a network-based scanner and an endpoint-based scanner, and we're building these software libraries for you, we can give you a consolidated view of your asset to help you understand, like, okay, here's the asset, here's the identities logged into it, and here's the actual vulnerability picture. And again, it might not be like a universal acknowledged truth, but like every enterprise has vulnerabilities. And I don't mean like O-Day vulnerabilities. I mean, a new update for Chrome. I'm not sure when this will air, but I mean, a new update of Chrome came out today, right? Today, 100% of your assets running Chrome are vulnerable. You're not going to patch 100% of those today. So it's not like the old days where, when Patch Tuesday came out, like, okay, I know on Tuesdays all my vulnerabilities are gonna everything's vulnerable, and then I'm hopefully gonna roll these out in a day or 2 or 3 days. But now with this like constant patching cycle, which is great from all the vendors, you want to have like a view of where your vulnerabilities actually live across all the different reporting structures, which can help you to define like, okay, let me understand the how likely these vulnerabilities are to be exploited, what hosts these are on. Is this like a crown jewel asset for me, or is this some guest workstation? But part of that is really having that holistic view of all your assets and all your identities from all the different providers, because like what shows up in Okta is different than what shows up in Azure, which is what shows up. There's local accounts, there's guest users, there's work from home, there's VPN people. And we're finding that a lot of enterprises just don't have a holistic view for assets, identity, and software libraries, inside their enterprise.
Well, one of the other pieces from StrikeReady that I've thought kind of brilliant is this concept of strikes. And if I was to sort of quickly describe strikes, they're mini threat emulations, almost to go test, am I vulnerable to this malware or attack? Now, I kind of think of this a little bit like you've got airbags in your car, but you don't know how well those airbags are going to work in a crash until you go test them. Of course, you don't want to go crash your car. That's an expensive exercise to figure out do they work. And to some extent, assurance and security has been a bit the same, right? You pay for expensive pen tests or threat emulations and or some form of red teaming exercise, and these things tend to happen somewhat infrequently because the cost and it's not something that you can often just do as part of a day-to-day cycle of, hey, I've updated this, I've done this, I'm just going to test this here and make sure that this is working as expected. Now, strikes, you can very quickly go deploy little tests. Where does that come from? It doesn't seem to be something that's widespread capability. It seems to be something quite unique that I've seen in StrikeReady there. Can you just expand on that a little bit and where this concept's come from, how you've seen it being used?
Yeah, so it came from us at FireEye. So when we all worked at FireEye, customers all the time would be sending us threat reports. They'd be, FireEye put out great threat intel, but they'd send us a threat report from CrowdStrike or from, Symantec or whomever, and they give us a threat report and they say, hey, I read this cool thing from CrowdStrike. Like, do you detect it, FireEye? And we'd be sitting there and we had like labs set up where we try to get the files and we try to load them on the system and try to trigger the alerts and see what the alerts look like and make sure things are working end to end. Because, a lot of times, and not every vendor, and obviously, when a vendor says like, yeah, we detect something, that might not be true in your environment, or it might be that you have to have the product configured in a certain way. And the vendor might not have any idea. Like, are you deployed in alerting mode or blocking mode? They might not have the telemetry. Like, are you paying attention to all alerts, or are you only looking at critical alerts? So when we say like, oh yeah, we detect something, well, if you're looking at low severity events and you have it in this like beta mode and you have this engine turned on. So the problem that we're trying to solve here is that when a SOC gets a threat report, they need to know very quickly, do their tools detect it in their environment? So what you do is you feed a report into the platform, or you can subscribe to things, you can automate all this. But you feed a report into the platform, it has hashes, it has URLs. On the endpoint side for the hashes, we'll go and find the file for you. So the platform does it. Right? We have crawlers, we have lots of file databases. You can give us the file if you have it. But we'll go and find the file based on the hash. We spin up a virtual machine in your environment. And in that virtual machine, it's running your EDR agent and it's running our simulation agent. So we take the file, load it into the simulation agent, and your EDR is running, and we allow it to scan it. And then very quickly, you'll understand, like, does my EDR stop this thing? And when it does, what does the alert look like? Like, what's the name of the alert? Because it might be like downloader.generic, or it might be superbad.apt.apt28 or something like that. So that helps your SOC understand, like, what does my EDR say about this? What does the alert look like? And like, would they even notice the alert? So I'm not sure why this concept isn't more widespread. But it's a different problem than like the red teams, which you talk about, or the breach tech simulation. The red team is really answering, can a really smart person break into my network? And a breach tech simulation is kind of like, okay, given this CVE or this malware, if I encode this 8,000 different ways, can I sneak some of these past your tools? And those are all like very valuable things to do. This is testing, like, if I saw this actual attack, what would my tools say? So we do that on the endpoint and we do that on the network. So on the network side, like, we'll simulate beaconing out to badsite.com or pulling down a malicious payload. And it's not actually going to the attacker infrastructure. It stays controlled, but it's getting passed through your network devices so you can understand, like, would they stop this? And then the second part is obviously, okay, it stopped 9 out of 10. That 10th hash or that 10th URL, let's push out a blocking rule. We'll push it out to CrowdStrike. We'll push it out to Palo. We'll push it out to whatever your tools are, and we'll block that in your environment. But obviously, you don't want your blocks to live on forever. A URL is bad today, but that URL is not bad in 6 months. That's just kind of the nature of the way these things work. So we'll push out a block rule today. You can say you not just you could say, but you mitigated this threat. And then in 6 months or 3 weeks or a day or whatever, however you have it configured, we'll go and delete that blocking rule off all your tools so that your block lists don't grow to the sky and you can keep things nice and pruned.
Cool. One other piece is, StrikeReady is very early leveraging AI, and with Kara, the virtual SOC analyst, what would now probably call agentic AI, and we've called this angelic AI in the title of this because having that guardian angel on your side to help you out, incredibly powerful. That use of AI, how do you see that benefiting the SOC? And I guess where do you see this heading in terms of analyst augmentation versus full autonomy of operation, response, autonomous response type pieces?
So it's really useful as an analyst in a bunch of different places. Like if you're talking about like an endpoint alert, it's really useful to understand, to be able to leverage these LLMs to say, like, okay, it was a PowerShell process and it had all these switches and command arguments and encoded content. It's really useful just to be able to like dump that into a locally hosted LLM. It says, like, explain this alert to me. Like, what is this thing doing? You could go and look up like how PowerShell or how command or how whatever the tool is, like, what these different arguments mean, but it's just so fast that it can really explain it very quickly. Same thing with like decoding. Like, it's not rocket science how to base64 to code something, or how to take something that's more obfuscated and do 10 loops of deobfuscation. But the LLM can just do it for you. And there certainly are hallucinations, but when it comes to like experts in this analysis, it's really it's going to solve you. It's going to save like 90% of your time when you can watch the logic of like, okay, it's carving this thing out. It's adds 1 every time this loop happens, and it works really well, especially for experts, to speed up the analysis time. And for junior people, the ability to just understand how a process is supposed to operate, or also just to document what you've done. Right, when you're doing an investigation and you're searching in one place and you're pushing out a block and you're looking at different alerts, to be able to document that and then create a summary of all your different actions. So much of the incident response process is like documenting all the work you've done, whether or not it actually had a finding at the end or not, but just being able to document all that and making it in a nice readable format. And then the reverse is true too, of taking a threat intel report and summarizing it and extracting the indicators and understanding where those indicators might live in your environment, where best to look for them. Those sorts of things are just intuitive to something that's able to like sit on your shoulder and watch how you triage things, and then make suggestions about how you do it, or about how maybe somebody else in your SOC, hey, you might want to go look at this source. Somebody on your team did a search through your email store. You looked it up on Proofpoint, but maybe not on Mimecast. Like, let's go and look in this other sources. So it's really a huge time saver, as long as you can do it locally. One of the big problems is that people want to use these tools and they want to just go on ChatGPT and throw all their alerts into it and say, hey, analyze this thing for me.
Yeah.
And, your data's gone. Like there's no more boundary. So anyway, so the first part is the boundary problem. The second part is obviously the hallucination problem of just not knowing the source of truth. But when you can build your LLM around your locally derived data, the hallucination problem goes down dramatically.
Yeah, awesome. So before we leave today, what's next for StrikeReady? What do you see coming in the next, window of time? StrikeReady, the industry. What do we expect to see?
So I mean, for us, the next big thing is the ability to really visualize all your telemetry. So today we're really just gathering alerts, but there's a number of telemetry sources that aren't millions of EPS. Like, we don't want to compete with, ArcSight or Splunk or something, capturing a million EPS, but there's a number of telemetry sources that are hundreds or thousands of events per second that are super useful in the incident response digital, the DFIR process. So endpoint telemetry and email-based metadata and NetFlow and authentication logs, things like that, we want to be a place where you can ingest those and then write Sigma rules or generic regex on top of your inbound telemetry sources. So that's one of the things I'm most excited about.
Cool. So really, I guess, good way to expand that kind of field of knowledge within the platform, right? And sort of enrich and grab that broader context. Hey, Alex, thanks a lot for joining us today. That's been really useful. Love chatting about this stuff, and look forward to catching up again in the near future.
Absolutely. Thanks for having me.
Cool. Thank you.